So today we're going to talk about measures of center or measures of central tendency. So the three measures of center that we are going to focus on are the mean, the median, and the mode. So for the mean of a sample, so we're going to look at sample and population, but our sample is also referred to as the average. A sample mean is denoted with the symbol x bar. And so to find the mean of a sample, we add up all the observations from the sample and then divide the sum by the sample size, or n. So our mathematical formula looks like this. X bar is equal, so it says the sum of all x's divided by the sample size. So let's take a look at an example with this. So we have, example 1 says, below is a data set on the exam scores for 15 students in a college math course. So I have all their different scores, and we want to find the mean exam score. So, so I have x bar is equal to the sum of x all over n. So they already told us the sample size, it was 15. So my denominator is going to be 15. And what we need to do now is add up all of the data points, all of the 15 points that I have. So I'm going to do that on my calculator. So I can do, just add them all in. 72 plus 82 plus 78 plus 90 plus 75 plus 72 plus 68 plus 87 plus 70 plus 74 plus 65 plus 19 plus 72 plus 74 and 96. So we get a total for my numerator. All right, so 1094. And so what I want to do is just divide that 1094 by 15. So I can hit just the division, divided by 15 in my calculator. And it doesn't say where to round, so let's round to 2 decimal places. So 72.93, that would be the average exam score for this exam out of the 15 students. So if I look at all of the pieces of data, you may notice that there's sort of one score that's fairly low, compared to all the other ones, and that one's the 19. And so if we think, we're going to talk about what this 19 does to the mean. So the second part says recalculate the mean score excluding the exam score of 19. What does this tell you about the mean as a measure of center? So you could add these all up, but we know, we know that we're just going to exclude the exam score. So if I think of my sample mean, it's all the sum of x's over n. Well, we're just excluding the 94. So if I subtract 19 from 1094, and then instead of the 15, pieces of data, we're going to have one less, So we're going to be at 14. And if I take 1094 minus my 19, my new numerator is going to be 1075. So 1075 divided by my 14, you'll see that my average now changes to roughly 76.79, So it definitely, moved it up. So when we're talking in terms of the measure of center, and we have maybe a data piece that is far away, sort of an outlier from the rest of the data, it definitely affects the mean. And so we would say that the mean is not a resistant measure of center. So if you had an outlier in your data set, whether it's a really small value or a really large value, and you calculated the mean, that outlier is going to influence the mean. It's either going to shift it higher than it should be or lower than it should be. So, if we exclude that 19 from my data set, that 76.79 is sort of more of that theoretical, right? That mean that we would expect, because more of the data sort of are around that area. So that would be my sample mean. So let's take a look, right? And just talk about my population mean. So it says, note that the mean of an entire population instead of a sample is denoted with the symbol mu. So mathematically, the formula looks like, so we have mu is equal to x all over a capital N, where now N is the population size. Now, there's different notation, right? Different variables, one's capital, one's lowercase, but the way we find the mean for population versus sample is exactly the same. The only thing that's different is the symbol used to denote what type of mean it is. So if we see mu, that's understood to be the population mean. If we see x bar, that's understood to mean the sample mean.